In these examples, we're going to find first find the limit, and then we are going to find a value of delta that corresponds to this choice of epsilon. Right, so this is our value of epsilon here. So we're going to try to find a value of delta that will make that true. But first, we need to find our limit. All right, so here we have the limit as x approaches 4 of 3 plus x over 2. If we were to just plug 4 into that function, you're going to get 3 plus 4 over 2, which 4 over 2 is 2, plus the 3 is 5. So this appears to be heading towards 5. I'm going to claim that is the limit. Let's see what value of delta we would need to have. So we need to have the absolute value of f of x minus L is less than epsilon. So for us, our function f of x is 3 plus x over 2 minus our value of L. We are claiming it is 5 is less than epsilon 0.01. We want to go through a series of steps so that we will end with the absolute value of x minus c is less than epsilon. Right, so the absolute value of x minus c, our value of c here is 4. That's what the x value is approaching in this limit, is less than delta. So that's where we're going to try to get. If we just do some algebra here inside this absolute value, we have x over 2 minus 2 is less than 0.01. And if we were to multiply both sides by 2, we have x minus 4 is less than 0.02. So our value of delta is 0.02. And our limit was 5 itself. Great. So there we had started with a value of epsilon. We figured out the value of delta. Let's do that again for a different problem. Here we have limit as x approaches 3 of 2x minus 1. If you were to plug 3 in directly, you would get 2 times 3 is 6, minus 1 is 5. So this limit also appears to be 5. And we are going to start with the absolute value of f of x minus L. It's less than epsilon. So in this problem, our function is 2x minus 1. Our value of L is, again, 5. Is less than our value of epsilon, still 0.01. We want to go through a series of steps, so we have x minus 3 is less than some value delta. And so, let's just do some algebra. We have 2x minus 6 is less than 0.01. How are we going to turn this stuff inside this absolute value on the left? How are we going to turn that into an x minus 3? Well, we could factor out a 2 from that. And then divide both sides by that 2. So delta is half of 0.01, so 0.005 is our value of delta. And on that problem, again, our limit is 5. Perfect. In our next video, we are going to go through 2 more examples where we are going to find the limit, prove that the limits of some functions, using the definition of a limit, finding deltas in terms of epsilons. All right, we will see you there.